Hello, everyone, and welcome to our session today. The session for today is the life of an email with Steve Atkins. And just wait. Yeah, my name is Maike, and I'm responsible for the marketing and events at the CSA. And as you can see, we have someone new today. Julia, our director, is also part of the webinar today. You will hear she later, and she will introduce Steve, and you will see her and hear her at the end of the session again in our Q&A session. But first of all, to us, to the CSA, what we are doing all the day and how we can support you. First of all, our goal is to increase the quality of commercial emailing, and we act as a neutral interface between mailbox providers and senders, sorry, of commercial emailing, and we establish legal and technical quality standards in cooperation with our partners and, of course, our certified senders. And all these steps ends in our certification that we can offer for you. And if you want to get more information about the CSA and how we can support you, just contact us after the webinar and we'll get you everything you need to know about us. And we have two official partners doing the whole year, doing the webinar season this year. And the first one is Harlon, and our second partner is The Martian. And thank you both for supporting us during the webinars. And if you want to get more information about Harlon or The Martian or both, you can download our partner booklet in the download section. It might be on the right on your screen, and then you can find everything you need to know about our partners. And of course, we need some housekeeping rules, but they are very short and simple. You're muted during the whole webinar, but we have two functions today. You can ask your questions live by raising up your hand, and or you can ask your questions by using the chat function. Submit them to us, and we are here to answer your questions at the end of the session or during the session. We will see how it works. And yeah. Today's challenge, we have a challenge for you, but it's also simple. Share your key facts, your learnings, and takeaway with us about the session today with Steve. Share them via social media or send them to us. It's up to you, but we want to know, what did you learn today, or what do you want to ask after it again? Just contact us and we will help you to answer all your questions, of course. And now I'm happy I can hand over to Julia and Steve, who will start the webinar, and you will hear me at the end of the session again.
Thank you very much, Maike, and a warm welcome from my side. Good evening, good afternoon, good morning, wherever you are in the world. Welcome to the session, The Life of an Email. I was truly blessed and lucky to see and listen to this session before, and it was truly blowing me away because a technical person was able to talk about a technical topic in a really inspiring way that a non-technical person like me could follow and understand, and found it really interesting. So we needed to have this webinar as a CSA webinar, and here we are today. Now let me introduce the speaker of today. He was in the email industry before there was an email industry. He is the truly, really technical part, usually behind the scenes of Word to the Wise. But in the front seat and as a presenter today, he has two kittens and maybe an Irish stew cooking in the back while we're speaking. Live from Dublin, where there's thunderstorm and rain today, Steve Atkins.
Good afternoon, everybody. And now you should get my screen rather than my pretty face for a change. So good afternoon. We're going to be sending some email today. That's really not that complicated, so we should have plenty of time to spare. Interrupt if you have a question, raise your hand, or if something isn't clear, raise your hand or ask a question in the question box. Now, I'm going to be doing this live, so what you're seeing here is my terminal window where I'm going to be typing commands in. if you would like to see the same stuff on screen in your browser so you can copy and paste things, you can go to class.wordtothewise.com and click on follow along, and that will show you exactly the same thing as you're seeing here. So email is old, like really old, like 50 years old. The first implementations that you'd recognize as kind of like the way we send email today were developed in 1972. So at the very beginning of email history, you wouldn't have a mail client. You'd connect to the remote machine where the recipient was, and you'd type the commands you needed to send a message by hand. Lots of extra things have been layered on top of that since then. Attachments, rich text, authentication, encryption, bounce management, all the fancy stuff we deal with day to day. But the underlying core protocol really hasn't changed much, and it's still simple enough to run an email transaction by hand. So let's do that. If you want to run the commands yourself, and I know all of you all do, then you can go to shell.wordtothewise.com and get a shell with the commands we're using today installed. So I'm going to send mail to one of my servers. If you're following along, you might want to do the same rather than sending to your own email address. I'll explain why later when we talk about SWACs. But for now, we're going to send some email to our lucky recipient, who today is discard@reject.wordtothewise.com. So first, we need to work out which server we need to talk to send mail to reject.wordtothewise.com. The domain name system knows everything about host names. So we're going to use dig to ask the domain name system where things need to go. Dig is a tool for querying DNS. It's useful for looking up host names, finding mail servers, checking SPF records, and all sorts of other neat DNS-based things. There are some really nice web-based DNS tools you can use that'll give prettier results, but dig is quick and easy to use, so it's what I'm going to use here. Other tools you might have handy for DNS are NSLOOKUP or Host. NSLOOKUP is kind of janky, avoid it if you can. Host is great, but I prefer dig. So we want to work out where we need to go to send mail to reject.wordtothewise.com. If I can spell my own domain name. So there we do have dig is the command. Then plus short is that flag there, and that just tells dig, give us the result, not all the other information you know. All the other information is kind of useful if you're diagnosing DNS issues, but really kind of scary if you're not used to it. So we're just going to use plus short for everything right now. That's reject.wordtothewise.com is where we want to look up. And MX means we look for the mail exchanger. MX stands for mail exchanger, so I've no idea why it's MX and not ME, but MX it is. So we're going to ignore that 10 at the beginning for now. We'll come back to that later. So the server stuntmx.wordtothewise.com wants our mail. So we use the internet for a lot of things. A single server can do a bunch of things at the same time. It might be both a web server and a mail server. We need to tell it what we want it to do. We need to tell it which protocol we're using today. So we want to talk to it on a particular port. A port is just a number. Web servers serve web pages on port 443. DNS servers serve DNS on port 53. Mail servers we talk to on port 25. So we now know we need to connect to stuntmx.wordtothewise.com on port 25. We're going to use a tool called Netcat for that. Netcat is a tool for connecting to a remote server on a port and talking to it. It's the quintessential Unix command line tool in some ways. There are at least 3 or 4 different versions of it that sort of do the same thing, but are subtly or not so subtly incompatible with each other. Also, it's called Netcat, but it's usually installed as NC. Unix users, they don't like typing long words. So we're going to use Netcat to talk to our server on port 25. That's an uppercase C at the beginning. It's telling netcats to use the right sort of line ending. Some netcats use a lowercase c for the same thing. So if you try one and it gives weird errors, try the other one. So we've connected. That's the mail server telling us that we've connected okay, that its name is stuntmx.wordtothewise.com. You can see that line begins with a 3-digit number. The first digit is a 2, which always means everything is okay. We should say hello and tell it who we are. Hello is spelled EHLO. It used to be spelled HELO, as that's a 4-letter way of spelling hello, and they wanted to keep the command short, maybe. Then they needed to modernize it to add some extensions. They spelled it EHLO instead, for extended hello, I guess. So that's a multi-line response. Again, it starts with a 3-digit number, and that begins with a 2, so everything is good. Anytime you see something beginning with a 2, that's a good response. Each line of the response starts with the same code, and the server tells us its name again, stuntmx.wordtothewise.com, and then it tells us about all the extensions it offers, which we're going to completely ignore for now. So we keep going like this. We send a command, the server responds with a message starting with a 3-digit code. First thing we can do is say, I'm going to send some mail, and it's from me. So I'm going to do mail from Steve at wordtothewise.com. So we're sending some mail, and it's from me. The email address here isn't the one you'd see in a from header. It's what you'll see called a bounce address, or the envelope sender, or the return path, or the 821 from, or lots of other names. But it's the email addresses bounces will be sent to. And if you're ever doing with SPF, this is the email address that's relevant for SPF. For this mail we're sending manually, or most one-to-one mail, the address will usually be the same as the address in the from header. But for any sort of mail where we want to handle bounces automatically, any bulk mail, it'll usually be the email address of our bounce handler. Oh, and yet you do need the angle brackets around the address or stuff won't work. So the mail server responds with a 3-digit code, 250, so it's all okay. So now we want to work out who we want to send the mail to. We're going to send it to discard at reject.wordtothewise.com. I should either get a shorter domain name or type faster. So again, we get a response from the mail server with a 3-digit code, begins with a 2, so everything is fine. It likes that recipient. So now let's send the content of the mail itself. And this is in what's called the data part of it. We send data, and that says we're about to send you a mail. Again, it responds with a 3-digit code. This time it starts with a 3, which means that what I said was okay, but the server is waiting for something more. It wants me to enter the payload of the message here. So we're going to type in some email headers. So we're sending it to steve@blighty.com. Note that that's a different email address in the to header than I did in the receipt to command, and I'm just doing that to show that I can. They'll usually be the same email address for one-to-one mail or for personalized bulk mail. But if, say, you're CCing mail or BCCing mail or forwarding mail or whatever, you might well have mail being delivered to somebody who isn't in the to header, and that's where they'll be different here. You can see that we're going to send it from the same person. You see the headers start with the name of the header and a colon and then the value of the header. 1 per line for short headers. If the header gets longer, there are ways of wrapping the lines, but everything we're doing here is going to be really short. So it's an email, so we need a subject line. And I should add a date header here, but I can never remember what format email date headers are, so we'll just skip that. And we can add any more headers we want here, 1 per line. Then we send a blank line. That means it's the end of the headers and the start of the body of the message. The body of the message is just plain text, so you can type anything you like here. And we're done. That's the end of the message. The server is just copying everything I type into the message though. So how do I tell it to stop? We just finish with a full stop on a line on its own. And again, we get a 3-digit response, and the server has seen the whole headers and the whole body of the message. It's happy with what it sees. We get a 250 response, and the server has taken responsibility for the message here, and it's promising it'll do its best to deliver it. If it fails later, we won't see anything here, but we might get a bounce message in an email sent to the email address we gave it in the mail from command, which is why that's called the bounce address. We could keep going here and start again with mail from to send another email while still connected to the server. But instead, I'm going to quit. And that's it. We sent an email successfully. That is all there is to sending email. We send a command, we get a response back starting with numbers. Responses beginning with 2 or 3 are good. Responses beginning with 4 or 5 are bad. So I'm going to go back to something I glossed over earlier. Remember, we used dig to look up the host name we need to send mail to. We got a nice simple answer. In the real world, it's often not that simple though. Let's, for an example, let's look at what happens if we want to send mail to Gmail. Same as we did before, dig plus short, gmail.com, mx. This time we get 5 answers. Why do we get 5 answers? Everyone really wants mail delivery to be reliable. That's been something we've wanted ever since MX records were invented in the mid-80s. We want mail to keep working and keep delivering, even if a mail server falls over. In 2022, we do that with load balancers and high availability clusters and diverse routing and all sorts of other network layer magic. In 1987, not so much. So Gmail are advertising 5 mail servers, all of which will accept mail for our gmail.com recipient. And if one isn't available, we can try another one. Rather than picking one at random though, Google would like us to use their main mail server first. That's the one with the lowest preference, in this case 5. So Gmail smtpin.l.google.com is the host name with a preference of 5. So that's where we should try and deliver to. So let's do the same thing we did, but this time we're going to try delivering to Google. And yay, we've seen that before, but this time it's the response from Google telling us that we've connected there. Now, I'm not going to send mail to Google, so I'm just going to stop here and exit out there. We're done. So if we couldn't connect to that one, we'd try connecting to the one with the next highest preference, with preference of 10. And if that failed, the next one, and if that failed, the next one. And we'd keep trying them in order of preference until either we've connected successfully or we'd run out of servers. On the modern internet, they don't fall over much, so we pretty much always sending mail to the mail server with the lowest preference. But sometimes they do, sometimes you have to go through MXs. What happens, say, if we wanted to send mail to Yahoo instead? Dig plus short, yahoo.com, mx. Here, Yahoo's telling us they have 3 mail servers, and they all have the same preference. And that means that Yahoo don't care which one we send it to. Pick one at random. If that one doesn't work, pick another one at random. So that's pretty much everything you need to know to send mail by hand. You look it up with dig to find the mail server. You use netcat to send the commands. You sent mail. And it kind of feels neat to be like a hacker and be doing all that fast typing like you're on NCIS. But it's too much like work to do on a day-in, day-out basis. So we're a tool using monkeys. So like monkeys, let's use tools. There's a neat little tool called Swax. Swax stands for Swiss Army Knife for SMTP, and they're not kidding. It has a ridiculous variety of options for sending mail. Most of them are designed for testing bits of your inbound mail system to see what happens when something weird comes in, whether your filtering is set up correctly, whether your mail routing is set up correctly, whether everything works. It also stands for sealed with a kiss, apparently. So it's a very powerful tool. We're going to use a tiny, tiny, tiny subset of what it can do to send some mail. Swax. Then we say --2, and that just tells it we're going to give you the email address to send it to. And we're going to send it to the same place we did at the very beginning, discard@wordtothewise.com. And now, wait for it. What it did there was it just did all the things we did before by hand. It looked up what mail server to send to, and then it sent all the commands. You can see that the output, most of the lines start with a little arrow. For responses we receive from the server, the little arrow points to the left. For commands we send, it points to the right. We didn't tell it what server to connect to. It did all the DNS lookups to work that out from the recipient's address. We didn't tell it who to send the mail from. It made up an email address based on my username and the host I'm running Swax on. And it just sent a canned test message. You can override any of those things, all sorts of others, but if you just want to see if mail delivers, those defaults are often good enough. As well as making things simpler, Swax is also fast. If you're typing SMTP by hand, you'll often find a mail server that times out and just forcibly disconnects you before you finish typing. I've not found any that you can't talk to by hand, but I've found quite a few where you have to type really fast and not pause to think. Swax avoids that. That's why I warned you off sending email to your own mail account when we started. You can use Swax to send that and everything will work fine. It works just like any other mail client, except it shows you everything it's doing as it goes along. So I think in the summary of this talk, I promised to talk about how it helps diagnose some sorts of delivery issues. So let's talk about what happens when the mail server doesn't like us and doesn't respond with a happy 2XX response to everything. So there are two broad classes of delivery failures. There are rejections and there are deferrals. Let's see what a rejection looks like. We're going to send mail to reject@reject.wordtothewise.com, which is an email address set up so that it'll reject it. You can see here that the server responded to the receipt to command with a response that didn't begin with a 2. It responded with a 554 response code. Any response code that begins with a 5 is a rejection. That means that this mail was rejected. You shouldn't try and deliver this particular mail to this particular recipient again, at least not without some human intervention. For personal mail, that means you'll get a bounce message in your mailbox. For bulk mail, it'll record that this message delivery failed in your database. The other type of mail failure you'll see is a deferral. So let's see what one of those looks like. This time we're sending mail to defer@reject.wordtothewise.com, which is another stunt email address. This time we'll defer it. You see it looks the same up until receipt 2, and then we get a 3-digit response from receipt 2 that's a 451. Any response that begins with a 4 is a deferral. It means that something went wrong with this delivery attempt and the mail wasn't delivered successfully. But as the mail sender, that mail is still your responsibility, and you can try and send the exact same mail again, and you should. That will usually be handled automatically by your mail system. It'll store the mail that was deferred and try it again in a few minutes. It'll keep retrying for some length of time, hours, days, a couple of weeks sometimes, and it'll keep being deferred. It'll finally give up, and when it gives up, it'll escalate the repeated deferrals to a rejection. For personal mail, you'll get a bounce message. For bulk mail, it'll just be marked as bouncing. All of this only applies to delivery of this specific mail to this specific recipient. It doesn't mean anything about delivery of mail to other recipients or delivery of different mails to this recipient in the future. Neither SMTP nor any of the other email standards says anything about whether you should try and send future emails after one is rejected or not. So should we remove the recipient from a mailing list or not? That's bounce management. There's no standard for it. There's no common definition of soft bounces or hard bounces. That's all stuff ESPs have made up independently. So everyone does it slightly differently. The only time SMTP really talks about bounces as opposed to rejections at all is asynchronous bounces. That's when the recipient mail server accepts a mail for delivery, sends a 2XX response after data, and promises to take responsibility for that mail, but later discovers it can't really deliver it to the final recipient. Then it'll send a bounce message to the email address we gave in the mail from, the bounce address. And that's kind of the same as a rejection. But asynchronous bounces sent in response to legitimate email are incredibly rare on the modern internet. So almost all the time we're talking about bounce management. We're making decisions about whether to send future mails in response to their history of rejecting delivery with a 5XX response. You've got to look for those really rare asynchronous bounces as well, but they're a tiny, tiny, tiny fraction of what you describe as a bounce. So in the olden days, back in the 70s and 80s, delivery failures were mostly due to server or network problems, or the recipient just plain not existing. Now, though, rejections and deferrals are due to spam filtering as often as not. So what extra information can we find out about why something was blocked? The most important thing is, if you get a rejection message, read the rejection message. So I'm going to send mail to helpful@reject.wordtothewise.com. And you can see that this is another rejection. After the receipt to, we get a 557 response, which is a little different. But again, it starts with a 5, which means that it was a rejection, a permanent failure. SMTP itself only looks at that 3-digit code, but there's usually something useful in the bit after that, the human readable bit of the response. Here it says mail rejected, see, and gives you a link to click on. Sometimes, like this one, it'll be a link you can follow to a longer explanation, which will explain why you were rejected, what you might want to change to stop being rejected. Sometimes it'll, instead of being a link, it'll be an explanation of why a particular delivery failed. Sometimes it'll include a recipient-specific code that tells you how the recipient is classifying the mail. Like if you see a rejection with PH01 in it, that means the recipient thought it was phishing. If you see a rejection message with TSS04 in it, that means it's due to recipient complaints about content. You can look up those magic cookies, just Google them. You'll find people talking about them, and that'll tell you why it failed. And if you go to the postmaster page of the ISP you're sending mail to, that'll usually tell you what at least some of those cookies mean. And so from just looking at these messages you get in the rejection, you have a much better idea of what you did wrong. So if you only remember one thing about delivery troubleshooting from this today, it's that the actual rejection message sent by the recipient's mail server can be incredibly useful. If your ASP's reporting hides that from you, ask them how you can see the real rejection messages. We've often, when we're consulting, dug down into why a client is having issues and found that the ASP's reporting either hides a useful detail about why something is being rejected, or even that the reporting is plain wrong. Some ESPs I won't name will actually list mail as being delivered successfully, even when it was actually rejected with a 5XX response. So you should definitely work out how to see the rejection messages, and ideally the deferral messages, so you know what they normally look like, and you can recognize what's normal and what's not when you're diagnosing a problem. If it's not clear in your ESP's interface how to get access to that data, reach out, ask your ESP, how do I see my rejection messages? And it's worth knowing about the deferral messages, as sometimes they're an early warning. For instance, Yahoo will often just defer messages because their servers are busy, but they're more likely to defer messages if their servers are busy and they don't like mail from you. And sometimes they'll just defer all messages from you for a while, and they'll include a TSS04 cookie in the deferral message, meaning your mail is causing complaints from recipients. And if you then don't fix that problem, your delivery is likely to get worse at Yahoo and everywhere else. So the deferral messages there can act as a canary in the coal mine, showing you that there might be something wrong with what you're doing. The quality of your mail might not be up to scratch, and stuff might start going downhill. So they give you early warning to fix things. So everything we've seen so far, the deferrals and rejections have all happened after the receipt to command, when we said we want to send mail to this recipient, and the recipient says no. So that's not the only place they can happen. They can happen anywhere in the SMTP transaction, and the different places they happen kind of mean different things. So they can happen even when you first connect to the mail server. If we're diagnosing a rejection due to spam filters or other reputation-based filtering, it's useful to think about what the recipient mail server knows about us when it rejects our email. So this is about as bad as it can get. This means we tried to send mail and we weren't even able to connect to the server. We didn't get, wasn't able to do anything. It means that the remote mail server isn't accepting any connections from us at all. Now, it's incredibly rare that a legitimate source of email will be blocked at the network level like that. It's far more likely that the domain you're sending to doesn't exist anymore, or maybe never did exist. Maybe it's a bad email address, or the recipient mail server is dead, or there's a serious network problem somewhere. If somebody really hates you, though, you're not likely to get blocked at the network level even then. You're more likely to see something like this. Here we connected to the remote mail server, and instead of that banner saying hello, the very first thing we get is a 5XX response. 554, no email here. All the recipient knows at this point is your IP address. So if you're rejected here, it either means that the recipient server has a serious problem and is not accepting mail from anybody, or that they don't want to see any email from your IP address. If your mail is deferred here instead, it could just mean that the recipient mail server is overloaded. You'll often see that at Yahoo, for instance. Or it could mean that your IP reputation isn't good enough to get red carpet delivery, and it's deferred, you'll retry. Maybe you'll get a successful delivery next time. So it doesn't mean that much, but it gives you an idea that something may be wrong with your reputation. So after the connect, the very first thing we sent was a mail from to say who the mail was coming from. And we could get a deferral or a rejection there as well. This is what it looks like if you get a rejection in response to mail from. Here, the mail server is rejecting it when it knows your sending IP address and who the mail is from, but it doesn't know who the mail is to. So if you're an ESP, that probably means that they know which of your customers this mail is from, but they still don't know who you were sending mail to. So it's a broad brush block against, at the smallest, an entire ESP customer, possibly an entire ESP. All of these so far are pretty rare. You've got to have done something pretty bad to be getting blocked at this point. A far more common case is you'll get rejected after you try and actually send it to a specific email address. So here we're going to send mail to Dorothy. And here we get rejected after the receipt 2 with a 554 response. That's a permanent rejection again. This mail is never going to be delivered. At this point, the mail server knows who the recipient is, as well as who the mail is from and the sending IP address. And that means that it can make decisions based on a particular recipient, whether the recipient exists or not, whether the recipient has marked mail from this sender as spam in the past or not. And for historical reasons, this is the earliest in the transaction you're likely to see much mail rejected, even if it's rejected due to an IP address-based block. But the recipient hasn't seen the body of the message at this point, so you know that if you're rejected here, it's due to the reputation of the mail stream, the previous email sent from this sender to this recipient, rather than anything about the content of this particular message, because we didn't send the content yet. So, staying with the Wizard of Oz theme, let's send some mail to the Cowardly Lion. Here you can see that the mail from was fine. We got a 250 response there. Receipt 2 is fine, 250 response. It's perfectly happy to accept mail for lion at reject@thewordstothewise.com. We start data. We get a 354, go ahead, all fine. We then enter in the mail we're sending, which is just the vanilla SWAX test boilerplate. But then we finish the data with that dot and a line on its own, and that we get a 554 error there. At this point, you know that it was rejected due to the IP address or the mail from, the email address it was sent from, or the recipient address, or something in the body of the message. It's an increasingly common way of rejecting email. It means the recipient ISP has the entire content of the message before making a decision whether to accept the message or not, which leads to a bunch of different things. One is that the mail might have been rejected because of something in the body of the email. Maybe there's a URL in there that has a bad reputation. Maybe there's an image. Maybe there's a Bitcoin address. There are ISPs who look for Bitcoin addresses and identify Bitcoin spam by that Bitcoin address in the body. Or it might have been rejected because the body of the message looks like mail that's caused complaints before, even from a completely different source. That's not unusual in affiliate mail, for instance, where different senders of different levels of quality are sending much the same content. You might be squeaky clean, but if you're sending affiliate content and that same affiliate content has been sent out by some Chinese spammers and got widely blocked in the past, your mail might be rejected just because it looks like stuff that was blocked before. Or it might not be anything to do with the body of the mail. It might have been rejected at this point, even though the ISP made or could have made the decision earlier due to the recipient or the IP address. Maybe the ISP wants to capture the body to make future filtering decisions, even though they're not going to deliver this mail. That's not that unusual. Sometimes you'll get deferred at this point, and that gives the ISP time to think about the content of the message, see what other messages of the same content are delivered, and when you come back later, it'll decide whether to reject it or accept it. Or maybe they just want to reject it at a consistent point in the transaction, either for technical reasons, because that's how their software is built, or so as not to leak any information about why they rejected it. One reason to do that is to mitigate attempts at list washing. What is list washing? It's removing undeliverable email addresses from a mailing list before you mail them. And the reason you do that is to hide from an ESP that the list is of poor quality and to mitigate some sorts of delivery problem. A common way to wash invalid addresses out of a list is to start sending mail, like we did here, and see what response you get to a receipt to. If it's a 250 response, then that must be a valid email address. Otherwise, it isn't. And then you can quit out of that transaction and repeat that for the next email address on your list. And that means you can work out which email addresses on your list are valid and will accept mail and which won't, which is list washing. But if the ISP only rejects the mail after data, even if the recipient email address doesn't exist, then somebody list washing can't do that. Also, when there's a rejection or a deferral after data, the recipient has the content of the message, even though it wasn't delivered. Sometimes a receiver might load images or follow links in the body to look at related content, so they can make decisions about, is this email linking to bad stuff? Is this email linking to the same things we've seen in spam before? And they can look at that before they respond at the end of data. Or they may defer the message after data and then check the images and links later. So they'll have information about, is this good or bad mail, and they'll know to accept it or reject it next time. That might mean that you see opens and clicks before a mail was delivered, or you see opens and clicks even for a mail that was rejected and was never delivered. So what's the point of all this? Well, I think it's interesting. You might think it's interesting, but a good reason to know about how email is physically sent is to make it easier to recognize the myths and fairy tales people will tell you about email delivery. Even those myths and fairy tales that have been baked into bounce classifiers and open tracking software and delivery reporting and list optimization tools, a lot of them are based on theories about how email is delivered that just aren't true. So if you know how it's sent, you can recognize when somebody's pulling a fast one and explaining how their magic tool that'll magically optimize your delivery works. And another concrete takeaway is that it's useful to know both what the rejection message was and when in the transaction it happened. Knowing how to extract that information from your ESP gives you another great tool to diagnose delivery issues. And if you can get regular reporting on that level of delivery data, it can let you see delivery trends you might not spot otherwise. So keep an eye on what's happening. See if the number of rejections goes up. And if you see in that reporting something weird happens, you can try and replicate it with SWACs. Send mail to the same recipient. See exactly what's going on. And that's it. That's all sending email is about. if any of you have any questions, feel free to put your hand up and ask them now. Or if you have any questions later, feel free to email me or ping me on Twitter. My contact information is there.
Steve, thank you very much for letting us look behind the scenes what's actually happening after clicking the send button. It's like I said before, for a non-technical person, it's truly inspiring because on the one hand, it's pretty simple. It's a question and an answer. And then on the other hand, it's getting complicated if the answer is not what you expected. And I could truly see an analogy between the server as server speak and also the human conversation, right? So if we have a good conversation and you give a response to me, if I ask a question, that's fine, and we're going to end up with a conclusion. But if the response is not as expected, if you have the goal to keep the conversation running, you have to be really screening your interview partner or your conversation partner to get to know why are you reacting like that, right?
Yeah.
It's actually the secret for relationships and for good conversations in general, what you just explained. So we can have those takeaways, and take them to other levels as well. Thank you very much. And what do you think, because you have a lot of practical experience as well, what are the most common mistakes, and actually what are the consequences?
The most common mistake is the one I stressed, is not reading the rejection messages. Okay. A surprising number of times I'll see on Slack somebody going, I'm getting really weird delivery problems. I can't get any mail into Microsoft. I can't get any mail into Gmail. I don't know what's going on. And all they're looking at is bounce counts in their ESP's reporting system. When we actually dig down and look at the rejections they're getting, the rejections are very clear. They say exactly why your mail wasn't wanted. They say exactly what the problem is, and generally tell you, what you need to fix. Maybe you need to better address acquisition. Maybe you need to change your content. Maybe you need to send more regularly or less regularly. And you can get hints as to what that might be from those rejection messages. So that's the most important thing, and that's the biggest mistake people make.
So read the rejection message. If you're talking to a human being, try to understand what he's trying to tell you what to do, right?
Yeah, listen as well as talk.
Yes, right. That's a huge challenge. I have some questions from the audience as well. Me as a brand, how can I check and prove the proper bounce management of an ESP?
That's tricky. At the simplest thing, you can send a mail that bounces or send mails that's deferred and see what happens. How can you do that? You saw the stunt mail server I used today. If you go to reject.wordtothewise.com, there's lots of instructions about how to use it. Feel free to use that all you like. Add some of those email addresses that bounce or are rejected to your lists. Send a little test mail to them. See how that appears in your ESP's reporting. See if a mail that's deferred looks like it was delivered. See if a mail that was rejected looks like it was delivered or not. By using those magic emails, you can test out your ESP. You can make sure that what they're telling you is true. And once you've seen that, you know what it looks like when a real email bounces or is deferred, so you can recognize it when you see it there.
Okay, cool. And another question is, where can people look and ask for help for bounce handling?
I think probably one of the best places to do that at the moment is the Email Geek Slack channel. There's a lot of people there who are deep into sending mail and know what they're doing, and quite a few of them are happy to help people out. If you've got like a serious business problem you need consulting, feel free to come talk to Word to the Wise. We can help you out with details. Okay.
Sounds like there's help for those challenges. That's good to see. And another question, any guidance, how many emails can be sent per connection, or do I need to open a new connection every time?
There is no consistent number. generally, I've got to explain some history to explain why this happens. And that history is about Yahoo, who again often show some interesting behavior. Yahoo found that because they were not accepting all the connections because their servers were overloaded, bulk mailers would connect to their server once and send all the mail they had and then just never disconnect. They would keep that connection open for days or weeks and just use that existing connection to send mail each time they had new mail. And that tied up resources at Yahoo. So because of that, they started saying, okay, you can't leave it idle for longer than this. And then people started just sending mails to tickle it to keep it open. And finally they said, okay, you can't leave it idle longer than this, and you can't send more than 100 emails in a single session or more than 50 emails in a single session. And that's a policy that now most ISPs have, but it varies widely what that limit is. So there is no one number you should put on all of your mail sends. It's absolutely fine to just send one at a time. That'll work. It's not as efficient, but you can. Send 2, 3, 5 at a time. If you actually want to start getting limits on it, those limits are specific to the ISP you're sending to. And ain't nobody got time to keep up with what the policies with all the ISPs are. So if your ESP or your smart host appliance provider gives you lists of, turn this flag on and will automatically limit the number of sends to a particular ISP, do that. Otherwise, maybe limit it to 10, maybe limit to 50, maybe let your smart host notice that it's being rejected after 50 and automatically throttle down. Some of them will do that. Keep an eye on your reporting. See if you're starting getting rejections at the 50th email you send each time. That's probably a sign.
Okay. Again, no standard as for hard and soft bounces.
Nope.
No. Okay. If you just checking if there are no more questions from the audience. If you want to leave the audience with 2 takeaways they have to remember when thinking about this session in 1 year, what are the 2 key takeaways you would want to leave them with?
Email is not complicated. Under the covers, it's very, very simple. So don't be afraid to sort of like crack the black box open and see what's going on inside. There are a bunch of tools that'll help you do that, or as you saw, you can even do some stuff by hand. Checking DNS by hand is often useful for diagnosing problems. So, don't be afraid of it. It's not that scary. And the other thing is, I'm going to say it again, read your rejection messages. Those are the 2 important takeaways.
Read your rejection messages. I got my takeaway, my personal find the magic cookies, you said. That's my takeaway. Thank you very, very much, Steve. It was really interesting to look behind the scenes, what happens after you click the send button. And yeah, I think we can hand over back to Maike.
Yeah, thank you, Steve, also from my side, and thank you, Julia, for your time today. And dear attendees, just click on our website to get more information about upcoming webinar this year. We will have another one at the end of the year. And thank you again for joining us today. And thank you, Steve, again for your time today.